all his accomplishments, or we'd be here all day and never get to hear him. But briefly, he's quite a famous astrophysicist. He's helped put stuff on the moon. He had a company of his own, Helm Communications, specializing in terrestrial and satellite communication technology. Has held high security clearances for many years, taught at the university level, and chaired a number of committees, and so on and so on. On the metaphysical side, he is himself a near-death experiencer. He serves very well on the board of the Virginia Beach chapter of the International Association of Near-Death Studies. He is scholar in residence at the ARE and enrolled in pre-doctoral work at Sophia University. So, if there's anyone who can walk in perfect balance in the twin worlds of pure physics and metaphysics spirituality, it's Neil, and here he is.
Thank you, Dick, thank you, and Dax, John, for that nice music. And thank you all for your prayers. For many of you perhaps who don't know, I've been fighting a strain of cancer that I've been fighting, and it looks like I've got it contained, and now we're just going to go after it with a lot of chemo and hope we can kill that beast. So, but thank you. I know that I've been in a lot of your prayers. You've contacted me, and a lot of prayer circles, and this particular congregation has been especially strong in supporting my health. So I really, really thank you for that. I got a Father's Day. Thank you. I got a Father's Day card from my wife this morning that I thought was so special. I wanted to share it with you. And the beauty of it is that you don't have to be a father or a mother or anyone, I think, to enjoy this. It says, "From the moment I saw you, I wanted to meet you. From the moment I met you, I wanted to know you. From the moment I knew you, I was in love with you. From the moment I loved you, I wanted to share my life with you." Happy Father's Day. Cheers, sweetie. Okay, science. Initially, I said that I would speak on quantum physics. Quantum physics is a part of some of the research I'm doing, long-term research on the bigger subject is called science and spirituality. For a long time, I used the words, and I may still use them from time to time, the fusion of science and spirituality. And then this year, I had an epiphany. An epiphany is for those of us who go, "Oh my God, why didn't I think of that? Everybody must know that except me." And the epiphany is that science in itself is good. It has its problems, which I'm going to talk to you about today. And spirituality does not need science to be perfect, to be viable, to write about, to speak about it. In our research, and mostly it's the research community, when we write something that is more spiritual or more mystic, the science community says, "Oh, well, I have to prove that, and if you can't prove it and test it and it isn't repeatable, well, it's not scientific method, and we can't publish it." I mean, we don't get published in the good journals, the science journals, the good science journals, if we want to write about near-death experiences. The only time near-death experiences are in the real good science journals is when they're debunked, supposedly. So we have that sort of fight between science and spirituality, and I came to realize that all we need are better journals of mysticism and better journals of spirituality where we can get our things published. And we can, work and research and study and with each other. And that's the way it should be. So we don't need necessarily science to make spirituality perfect. And so I'm going to broaden. So instead of just talking about quantum physics, I'll do that. I'll come back every year if you'll have me, and I'll do this series on science and spirituality, and I'll get a little bit more into quantum physics. But it's a bigger subject, and I wanted to start today by just giving you how we got to this dilemma of science and spirituality. The Greeks, and I won't spend time on, the age of reason, and we started this thing of everything is up here, nothing's here. Everything is up here. But the Greeks could work through it pretty well. When we got to the age of, quote, enlightenment, when we got to our Renaissance, when we got to the beginning of our Industrial Revolution, that's when, well, it started with Galileo, who was really the first person that mathematically could write that the Earth turned and all of this, and everything sort of worked mathematically. And then we went from there, and the age of enlightenment, supposedly, and that age of reason continued. And we had a series of dualities that have stayed with us to this day. And the first of the dualities is the difference between mind and matter. And in the relation of the two, matter ended up having a much higher significance. If something existed, and the laws are that way, our laws are deductive, and our thinking in a lot of areas are deductive. You start from the big thing and you go down and you go down and you go down, and you look at that little bitty, was there fingerprints on the gun? And if they aren't, the guy goes free. And 15 people said, well, I saw him shoot him. And they say, well, that's just your sight and your thinking, that has problems if his fingerprints weren't on the gun. So it's the objects and the matter that gain great, and still has great significance. And Newton came along, and then Newton wrote the physics and wrote the mathematics, which are still classical physics and mathematics, and we still study in our schools, the Newtonian physics, and we calculate things. Einstein came along with the speed of light, and we still use the speed of light in a lot of our calculations. But this dualism began to separate even more. In addition to the mind and the matter, then we also had body and soul. And the body, again, is the mind. So your thinking is what's valid. And if you have a soul, it's certainly not in your mind. We've never connected the soul to our mind. It could be somewhere else. But in the scientific method, the soul really doesn't exist. It's out there somewhere. But it doesn't really exist. It's not part of you. And so we've separated. We separated, first objects and matter, and then we separate from the body. We start separating things. And then with these objects, we give worth. And all of these little objects become worth. And we start fighting over them. All at once, instead of the river, everybody sharing it, some people say, oh, I own that river. And I own the mountains, and I own, things. And we've been fighting endlessly over this matter. It quote unquote has value, supposedly, value enough that we give our lives to it. We fight over land, we fight over objects. The French and the Germans have fought over Alsace and Lorraine, the coal and the iron that go up and down the Ruhr, and they fight over it and give it back and fight over it, and it's just coal and iron, it's just matter. And then that nationalism got into it. And we have to own things. And then during the colonial periods, we even had to go across oceans and own stuff that was a long way away. The British especially, the French, Germans, the Dutch came along. We have to own these people. We have to own things. So this whole age of science really is built on some dubious foundations. I mean, for everybody to say how wonderful the scientific method is, well, let's go back and look at it as we've just done a little bit. It really has some dubious foundations. And then there's things like, you know, is the speed of light really good? There's you can find Rupert Sheldrake is a British philosopher, really, and he toddled over to the metrology office. Now, metrology is a study of standards, of weights and measures. Meteorology is the study of weather. So you have to hear that. Metrology is the study of these standards. Well, he goes over to England. He goes over to the head of the metrology office in London, and he said, I came across this data which says the speed of light slowed down quite a bit from 1938 to 1943. And the chief meteorologist says, you're not supposed to know that. And he said, well, yes, it did, but we haven't told anybody. And in my work in space, we really riddled the motion, a lot of the laws of motion and the laws of gravity. I mean, when our spacecraft go over the Indian Ocean, for example, they slow down much more dramatically. And we must now surmise that there's an enormous amount of iron ore under the Indian Ocean that pulls. So all of again, when you look at all of these called constants, the speed of light changes, gravity changes. This is all, but people will get up and say, oh, well, you know, these are great foundations of science. These can't change, but they do. What we found, in fact, is that all of this stuff in Einstein sort of led us a little bit. First, it's relative. I mean, it's relative. It looks different from here than it does from here, and that's relative. And everything is relative depending on where the observer observes it. So we have relativity. That's the simple thing of relativity. His thing, Einstein is great, by the way, his quotes that you used earlier, Einstein, the one that I love about relativity, he says it's relative, like if you have your bow on a park bench and you're sitting there with your best bow on a park bench for an hour, it seems like a second. And if you put your finger on a hot stove for a second, it seems like an hour. So it's relative. It's relative. But Eastern thought, and our mystical thought, and our spiritual thought has much, much more seemingly goodness to it and direction to it, and it's where so many of us are going now. We're realizing that there isn't, you know, we don't need objects necessarily. We should stop fighting over objects and matter. Not to say that, you know, some things you need, but I'm so pleased that we can share air, we can share water, we can share oceans. I have a little bit to do with sharing of space. The United Nations group I spoke to, in having that space is shared by all humankind. The moon is shared by all humankind. I know we have a lot of military industrial types who would like that to be changed, but many of us wanted it to be that way, that we can have it for everyone, all humankind. So I can get a little bit into quantum physics. I was going to have us do. You can do it mentally. I was going to have us do a sort of a remote viewing thing. I was going to have us put our hands out and think of how far it is to look up to the moon. How far is it to the moon? 240,000, 239,000 miles, and sort of think about that. Then how far is it to the sun? 93 million miles. I'm going to do a little bit of figures. We scientists throw them around. but makes us feel important. So, the sun is a long further way away, 239,000 to 93 million. But still, we can see the sun. And more than that, we can see with the naked eye. I found this hard to believe, but this is what it says. I read it a number of times. On a given black night, we can go out and with 20/20 vision, you can see the constellation Andromeda with the naked eye. Now, Andromeda is 250 million light years away. Now, what's a light year? How long in that 93 million miles to our sun, how long does sunlight take to get from there to here? 8 minutes. 8 minutes. So then you do 8 minutes into 60 minutes into an hour into a day into a year. And that's a light year. And then 250 million light years. We can see that with the naked eye, with good vision. And you say, wow, we have that kind of power. Wow, we must be really important. You know, we have that kind of, we're blessed with that kind of vision. And then we say, well, how much of the cosmos can we really see? Can we see 50? We can see 250 million light years. How much can we see? Can we see 50%? No. Can we see 10% of all the cosmos? No. Can we see 1% of all the cosmos? 1%. No. We see about 1/20th of all the cosmos, 1/20th in that 250 million light years. We're looking for like that to that in our own single constellation. And there are a lot of constellations. And a little note, still get the NASA briefing every morning, a little note, and it was in a couple of papers, picked it up. In 2013, NASA said, oh, by the way, we have found an additional trillion stars, suns, constellations. And there's sort of a little note. Now we have 2 trillion. We used to have 1 trillion stars and suns. It's not all stars are suns. Some of them are going the other way, but most of the stars are suns. And we think that we have control of things because we can see so far. and in fact, we can't. We can't see very far, and we control very little. But yet, we think we do. We think we got everything. You know, we talk about only us exist. It can't be aliens.
Yeah.
You know, I mean, we only see 1/20th of 1%. 99% we don't even see, but yet we claim it. We think we own it. We think we can control it. I love this story, by the way. I'm a good storyteller. I like old stories. Gibran, Khalil Gibran. We all read him in freshman in college. It was fun. Those of us who did. And writing in Lebanon in the 20s, he looked off into the Mediterranean, and Khalil said, I wonder if there's two fish, and all the fish, and a big boat goes over the top of the propellers whirring. And the one fish says, gee, there's something up there. Another fish says, well, don't, let's disregard it. That's, by the way, what a lot of science does. Let's disregard it. Another fish says, well, it's making a lot of noise, and it's going up there. What do you think if there'd be another whole world above the water? The other fish says, oh, you're crazy. You can't live outside of water. Have you been eating that funny colored seaweed? So that's Khalil Gibran, 1920. We think we can control everything. We think we know it all. We really think we know it all. And we don't. And that's where, again, subatomic physics comes in. Because everything sort of above, if this is the atom, everything above the Newtonian stuff, this really flows pretty well. We understand that we can write equations for it. Everything below doesn't work that way. In fact, it doesn't work the way we write it at all. It has all these funny, it does different things. And it doesn't obey the laws. Shame on it. And that's where we're sort of going, more and more into that world, that wonderful world of subatomic stuff. Where, and you know, there are a number of experiments that you can do, but the fun things is that, and they call them quirks, quirky. They're quirky things. They're not supposed to happen. Like a particle operates in a certain way if it thinks you're watching it. and a particle, like they have two slots, and then the walls on each side, and two slots. And if the particle, if you're watching it, it acts like a bullet, and it goes through one of the two slots. Always consistent, pretty consistent. But if it thinks you're not watching it, it becomes a wave. It changes from a particle to a wave, and it goes like an ocean wave through both of the slots at the same time. And it changes its complete dimension from a particle to a wave, if you're watching it. So think of that particle, that subatomic particle, has cognition of some kind, has consciousness of some kind to make that decision that it knows, and it makes a decision whether it's being watched or not. And that just blows the minds of scientists today completely. That we can give cognition, we can give consciousness to that subatomic particle. Because that is going to give it real importance. And that's going to change the way we think about science. And just between us in this room, it's going to happen. It's going to happen. We're going in that direction. More and more and more. And it's fun. It's fun to study. It's fun to talk about it. It's going to happen. Perspectives. Perspectives. But we're now down at that subatomic level, and it, as Dick was saying, and as Elizabeth was saying, it's a oneness. Where everything in Newtonian is separate. Things are always nearly separate. They've got to be measured separately. When you get down in the subatomic level, things want to become one. You take a particle and you split it, and you move it apart, and you move one to the right, the other one will move to the right. You move it tens of thousands of miles. You move this one to the left, that one goes to the left. They really want to be together. They don't want to be separated. And things want that oneness, want that togetherness, that we do too. And that's why we're here in a place called a fellowship. Because we want that oneness, and we know that we're one. And at least we hope we're that one. And this is where this knowing and loving comes in. We know that we don't want to be separated. We don't like that. We know what's right and wrong. And we know that society is basically good. We should live together and help each other. We shouldn't go live in a cave. We should help each other. We know that. We know what's right and wrong. And we know the importance of love. And we know that the concept of love is good, that we love everyone indiscriminately. That's the concept. But then we can take love from a noun to a verb and say, we're going to take love and we're going to use it for forgiveness, and use it for compassion, and use it for doing things and helping people. and being active, actively loving. That's what it's all about. Thank you. Namaste.